What's up, YouTube? So today we're going to look at how we can use MIDI within Maximus P to algorithmically control the tempo of hardware. Let's get started. So we're going to begin by first creating a MIDI out object. This is what's going to talk to our hardware. So you can right click this object. Oops, make sure your patcher is locked, then right click the object or double click the object, my mistake, and you can choose whichever MIDI port you have access to that should automatically populate within this drop down menu. So I'm going to choose my Elektron TM1. So we're going to use three different MIDI messages. I'm going to use MIDI message 248, which determines the tempo, MIDI message 250, which turns the sequencer on, and MIDI message 252, which turns the sequencer off. So the MIDI message 248 determines the tempo, and it does that by transmitting this message 24 times per beat. So let's just start by creating a metro object. Whoops. Metro. There you go. And we'll connect that to this 248. And we'll set our time interval for the metro over here. Use a floating point for that. And we'll set an on-off. The on-off we can go and just directly connect to these on and off messages. So when this toggle is on, it sends a 1, which will hit our 250, which will turn on the device. When it's off, it'll send a 0, which will send 252. That'll turn the device off. And let's set our tempo. So right now we don't have any way to translate the milliseconds from metro into a tempo. We'll get to that. First, let's just set this to a random millisecond value. Let's say 50. Now let's hear how that sounds with our device. So if we turn this on with 50 milliseconds set as our metro, it sounds like this. And we can play with this metro value. So let's try changing that. So right now we're just using millisecond values. We don't have any sort of BPM. And we can determine the BPM by creating an object which divides 60,000 by an input. And this will give us a BPM value in milliseconds for any BPM. So here I'm connecting a floating point to this, which has 60,000 as the numerator, and then the input is the denominator. And I'll create an output for that. So our BPM originally was 98, so I'll put in 98. And you can see that the millisecond value is this floating point, essentially 612.25. And so if we have our 248 message going at 24 ticks per beat, that means we'll want to divide the output of our object by 24. So that'll give us new value. Let's see, it's 25.51, and then that is going to be our metro value. So here, this will be our BPM. So you can hit C, create a comment. I like to label parts of my patch just to keep myself organized. So here we have our BPM. We're finding out the millisecond value per beat. We're dividing that by 24, and we're using that to control the speed of our metro. Let's listen. So make sure that your BPM is set to 98 or whatever BPM you're using for your project, and then we'll turn on our metro. Let's listen. And now we can start doing some interesting things in terms of changing this value. So one possibility is to take this input value to your metro and modulate it by an LFO. So let's just create a phaser, and we'll use the phaser to drive different LFO objects. So we'll send that into a cos object, cosine object, and this cosine object will give us a sine wave, or a cosine wave, but close enough. It has the same basic shape. So let's give our phaser object an input value, and that'll be in hertz for now. Let's go into our cosine object. Let's see what the output looks like. So we'll take a look through the scope object. And you want to make sure your DSP is turned on by hitting this audio on button in the bottom right. And we'll give our phaser different values so you can see that there's this sine wave that's coming out of our cosine object. So we'll use that for now, and then we can play around with the LFO shape later on. And so let's just experiment with seeing what it sounds like to use this phaser and change the metro value by an amount that fluctuates according to the output of the cosine object. And so we'll want to scale that cosine object. So well, first we want to get out the value. So we can get out the value through our trusty snapshot object. And we'll use the output of this metro as the bang to report the value from the snapshot. Then we'll scale that value. So we'll multiply it by some floating point number. And we'll offset that value. So we'll add some value to it. So let's connect these up. So it can be a little tedious. And we'll just have our value displayed here so we know what we're inputting. So let's listen to that. So let's give that a listen. So we're going to end the tutorial there for now. There's a lot more to cover, a lot more that we could do. We could time sync the LFO rate. We can create sequencers that we then connect to the LFO depth. We can create more complex LFO waveforms. And we will do that for future tutorials. I just want to make this one short and sweet. And for those who already have some max chops to begin with, I'm sure that you can think of ways to expand upon this basic structure that we've covered. So I hope you enjoyed watching this. I hope you learned something. Please like, please subscribe. There are more tutorials and more music coming your way. So I hope to see you next time.